Alright, so in today's video, I'm going to be showing you number 2574, left and right sum differences in LeetCode. The problem is given a zero indexed integer array nums. So we're going to be working with an array that's full of numbers, integers more specifically. Find a zero indexed integer array answer where answer.length is equal to nums.length. So we're going to be creating an array that has the same length as the array that we were given or passed into the function. And for each answer I, so for each element of the answer array that we are creating, we're going to take the left sum and the right sum of the current element. We're going to subtract the right sum from the left sum, and we're going to find the absolute value of each one of those. And so this is where left sum I is the sum of the elements to the left of I in the array nums. If there is no such element, so for example, we're iterating over the nums array, we're in position 0, there is no left elements at all. We're at the 0 index, there's nothing on the left, then we're going to use 0 for the left sum. But for the right sum, if we're on this 10 element, for the right sum, we're going to use the elements to the right. Same thing if we're on the last element of the nums array, there's nothing to the right, so we're just going to use 0, and we're going to use the elements of the left side. So you can see right sum I is the sum of the elements to the right of the index I in the array nums. If there is no such element, right sum I equals 0. So if there's no elements to the right, then it's just 0. And then we'll return the array answer. So just to give you a couple examples, I already pointed these out. Let's say our nums array is 10, 4, 8, 3. So when we're on 10, we see that there's nothing to the left, so that's going to be 0. We have 3 elements to the right, that's going to be 15. So we would subtract, based on this here, we would subtract the right, which is 15, from the left, which is 0. We would get negative 15, but the absolute value of negative 15 is 15. So we'd push that onto our answer array, and we'd continue on. Now we're on 4. We have 10 on the left, 8 and 3 on the right, and so we would subtract 11 from 10. We'd get negative 1, absolute value. We'd push 1, move on to the next one. Now we have 14 on the left, 3 on the right, so we do 14 minus 3, which is 11. Absolute value is not going to make a difference here, it's still 11. And then we go on to our last one, and we have 22 on the left, we have 0 on the right, so it's 22 minus 0, and we go ahead and push that 22 onto the array. With this one here, there's only one element. There's 0 to the left, 0 to the right, 0 minus 0, and the absolute value of that is just going to be 0. We'll push that 0 onto the answers array, and we end up with one element. There's always going to be at least one element inside the nums array, so in no cases will it be 0. And it could be anywhere up to 1,000 elements, and then each specific element, the 10, 4, 8, each one of these can be anywhere from 1 to 100,000. So I'm going to show you 3 solutions. One's going to be a brute force, which is the most straightforward. One is going to be a prefix sum solution, building a prefix and a suffix array, which I would never use on a problem this simple, but it's nice to see it implemented on a problem this simple, so that when you come to a more complicated problem or a more complex problem down the road that requires this solution or could use this solution to solve it efficiently, it's nice to have already learned this method. And then we're going to do a one pass, which is the most efficient solution of all. So for our brute force solution, we're just going to iterate over our array, right? So we're going to have I here, and for each element in this array, we're going to calculate the whole left and we're going to calculate the whole right. And so what we're going to do here is, with each iteration, we're going to have our left sum and we're going to have a right sum, and we're going to iterate from 0. So from 0 to I minus 1. So we're going to iterate from 0 to the element just before I, and then we'll stop just before I, and we'll move from 0 to the element just before I, adding each element to the left sum total. And to calculate the right sum, we'll move from I plus 1 to nums dot length. So in this case, I plus 1 is the first index. We'll move from the first index to nums dot length index, calculating the total and adding each element to right sum. And then based on those calculations, then we will run our final calculation, which is math.absolute left sum minus right sum. So I'm going to go ahead and jot some pseudocode, but basically for each element, let me give you an example of what we got here. So when we're on the first element, we're going to start with 0, but I is but we're going to be using a J. We're going to be using another for loop within the for loop. So since J is going to be actually equal to I, so J will be 0 and I will be 0, we're only going to run this loop while J is less than. So we don't add anything to left sum. We try, but we never even go into that second loop. Then in this one, we go ahead, we initialize J as I plus 1, moving through. So J is going to start right here. We're going to add that to right sum. We're going to move to the 8. We're going to add that to right sum. We're going to move to the 3. We're going to add that to right sum. And then we're going to have 0 in our left sum, and we're going to have 15 in our right sum. And so let me go ahead and comment this out. I'll jot down a little bit of pseudocode so you can see what we're doing here. So first thing I need to do is I need to answer array. So create the answer array to store the absolute value of left and right sums. Now I could go ahead and just create that now. And I know I'm going to be returning this. So before I do anything, I could just return answer. I know that's what's coming back. All right, so what we want to do is we want to iterate over the nums array, one element at a time. And for each element, we want to initialize the left sum variable to 0. We want to find our left sum by iterating from 0 position of nums to 1 less than the current position of I. Adding each element to the left sum variable as we move to the right. Then we want to initialize the right sum variable to 0. And same thing, find the right sum by iterating from 0 position of nums to 1, or not 0 position of nums, but we're iterating from the I plus 1 position of nums to the end of the nums array, which is nums dot length position of nums, adding each element to the right sum variable as we move to the end of the array. And then we perform our main calculation. Okay, so we're going to do a for loop, let I equal 0. We're starting at the first position. We're going to go until we get to the end of the array here. And for each iteration, we're going to increment I by 1. And so we're going to initialize two variables. One is left sum. We're initializing that to 0 every time because we want to reset it. And we're going to do right sum equals 0. And then we're going to go ahead and we are going to iterate from the 0 position to the current position of I. So let j equals 0. It's always going to be 0. And we're going to go while j is less than I. Once it hits I, though, we want to break out of this. We don't want to include nums I in the calculation, only elements to the left of I. So j++. Now I can keep it all on one line. So we will do left sum equals nums j. So that's good right there. And then after we get our left sum, we want to do let j equals I plus 1. So we want to start 1 after. We'll do while j is less than nums dot length. So we'll go to the end of the array, j++. And then in this case, we'll do right sum plus equals nums j. So this will give us our left sum. We're going to move from the 0 position to just before the I, adding each element to the left sum. With this is going to give us our right sum. We're going to move from the element after the current position of I to the last element in the array, adding all of those to right sum. And then we will do our answer, push math.absolute left sum minus right sum. And that should be good to go. So let's test this out. We're getting 15, 1, 11, 22 on the first one and 0 on the second one. So let's test that out. Yes, 15, 1, 11, 22, and then 0. Let me post this into the LeetCode because sometimes they have edge cases. So we'll run this here. And it's working. Cool. So that's the brute force solution. If you have any questions about this, just leave it in the comments. Now we will move on to our prefix sum. So like I said, this is just overcomplicated for this problem, but it's nice to understand this method for later on. You're going to encounter a problem that is just going to be time limit exceeded with the methods that you know. And so this is going to be a really, really nice method to understand and know. And so the concept here is before we start iterating over the nums array, we build a prefix and a suffix array. So basically what we're going to do is we're going to create our prefix sum array initialized to the same length as nums, just filled with zeros. And then we'll do our suffix sum also filled with zeros. And so we have these two arrays. Now the idea here is we're going to take, first we're going to iterate from the beginning to the end of nums, and for each element we're going to add it to the prefix sum. So what we're going to do is first we're just going to take num0 and we're going to add it to the prefix sums, and then we're going to start iterating starting at position I. So at position I, we're going to add the nums I of position I plus prefix sum I minus 1. So we're going to be adding prefix sum I minus 1 to nums I, which is going to be 14, and then we're going to move to 8. And so here we're going to, same thing, add nums I to prefix sum I minus 1, which is the 1 index, which is going to give us 22. And then we're going to move to the 3, and we're going to do same thing, nums I plus prefix sum I minus 1, which is going to give us 25. Then we have our prefix sum. So what we're going to do is we're going to build our suffix sum next, and in this case we're going to iterate from the end of the array to the beginning of the array. So we're going to set the last element in the suffix sum to 3. We're going to start incrementing from the second to last position. So we're going to take this nums I, we're going to add it to suffix sum I plus 1, so 3. So that's going to give us 11. Then we're going to move to the 4. We're going to take nums I. We're going to add it to suffix sum I plus 1, which is going to give us 15. Then we're going to iterate to the left to our last element. And we're going to add nums I to suffix sum I plus 1, which is 25. Now the key here is when we are iterating over our main array and we do our iteration to perform the main calculation is if I is at position 0 or I is at the last position, then we just want, if I is at the first position, we want to return 0. We don't want to pull a value from this prefix sum. If I is at the last position, then we just want to return 0. We don't want to pull any number from here. But for example, if we're at this position here, say we're at the 1 index, then all we have to do is find our prefix sum I minus 1. And so when I'm at this element here, my left sum is going to equal prefix sum I minus 1, so it's going to be 10. Perfect. And my right sum is going to be suffix sum I plus 1, so it's going to be this right here. So since I already have the values built out, I only have to do one calculation. Now it's going to take a little bit more space, so the space complexity of this problem is O of n. You're building up the array, you're taking up more space in memory at the expense of performing just an O of 1 calculation when you're iterating over this array. So if I go to the 8 element, I could just, if I want to find my left sum, I just do prefix sum I minus 1, because I would be 2. So prefix sum I minus 1 would be the 1 position, and that's my left sum. 14 is my left sum. And then if I want to find my right position, I do suffix sum I plus 1. So always the position in the left minus 1 prefix is going to be my left sum, and suffix sum I plus 1 is going to be my right sum. And so let me just jot out some pseudocode for this one. So first thing I want to do is I just want to create answer array to store new values. We could just say let answer equals array. And then I want to create our prefix sum array and our suffix sum array. So create our prefix sum array filled with zeros, and we're going to create our suffix sum array filled with zeros. And so we're going to have suffix sum equals new array. We'll do nums dot, actually we'll do this several times. We're going to use nums dot length a few times here, so we're just going to create an integer here. So we'll just do nums and we'll fill this with zeros, and then same exact thing for our prefix sum. And prefix just means what comes before, suffix means what comes after, essentially. Just keep it simple for now. And so we have our array, we have our prefix sum, we have our suffix sum. Currently they're just filled with zeros, so it's 4 zeros in each one on this first example. And so next we're going to, what we want to do is we want to set prefix sum 0 to num 0 and set suffix sum nums dot length, or n minus 1, to nums n minus 1. So we want to set the last and the first. And so we'll just say set our first element of our prefix sum array to the first element of nums. Set our last element of our suffix sums array to last element of nums. And so we'll just do that quickly. We'll do prefix sum 0 equals nums 0. Easy enough. And then suffix sum n minus 1 equals nums n minus 1. So now we have an element in now our prefix sum looks like that, and our suffix sum looks like that. So I'm going to go ahead and build our prefix sum here, and I'm going to build our suffix sum here. So let's just say fill the rest of our prefix sum array by adding current value of nums I to previous prefix sum. Position. So I'm going to iterate from 0 to the end of nums.length. So we're going to say let I equal 0 while I is less than n, I plus plus. And what we're going to do here is we're just going to say prefix sum I, so the current position of prefix sum. We're actually going to start at 1 because we already added the first one. Prefix sum I equals prefix sum I minus 1 plus nums I. So we want to add the current element of I. So if we're at position 1, we want to add this 4 to the 10 that already exists there, 14. And we take that 14, store it in prefix sum I, so that would be there. And this is going to do the same thing, like I said, for every single one. So we're going to end up with that. By the end of this loop, we're going to end up with that right there. Then we want to do the same thing. I'll just add these comments here. We're just going to do suffix sum by adding the value of nums I to the next. Well, it's still technically the previous, so we'll just stick with that. So I'm also going to be using a for loop. The only difference is we're going to be initializing I to n minus 2 because we've already added the last element. The last element is n minus 1, so we're going to start at the second to last element, and we're going to go while I is greater than or equal to 0, and then we'll decrement I because we're moving from the end of the array to the beginning of the array. And so change that to suffix sum, and instead of the element that comes before it, we're going to add the element that comes after it since we're moving from the back to the front. Plus nums I, and we should be good to go. So this is going to give us 11, 15, 25. Good to go. Then we have our prefix sum and our suffix sums array. So let me go ahead and just so you can see what this looks like. Console.log prefix sum, console.log suffix sum. I'll show you the before and the after so you can see what we got here. So you can see initialized in the beginning of our code, we just have arrays with 0, and then this is what it looks like after our loops. So we always know what our sum is going to be. Now we have access to the sum because we pre-calculate our sums. So just comment this out. So last but not least, we have to iterate over our nums array. We have to find our left, find our right, which are O of 1 operations, and then we'll do our main calculation. So we'll say iterate over nums to find absolute value of left sum and right sum using pre-built arrays. So we'll just say for let I equals 0, we're starting at the first position, we're going until the end of nums, incrementing I on 1. So we'll find our left sum, we'll find our right sum, and then we'll push absolute value of left sum minus right sum to answer array. So like I said, if we're in the 0 position, we just want to return 0 for the left sum. And if we're in the last element, we want to return 0. Otherwise, suffix sum I plus 1. So what we're going to do is we're just going to do let const equals. If I is greater than 0, so if we're not in the 0 position, we just want to return prefix sum I minus 1. Otherwise, if we are in the 0 position, we want to return 0. And same thing for this. So const right is going to be if I is less than n minus 1. So as long as I is not in the last position, we'll return suffix sum I plus 1. Otherwise, we return 0. And so we're only going to return 0 once for left and once for right. We're just doing a check here because we don't want to return I minus 1 if we're in the 0 position. That's going to give us undefined value. Same with this here. And then last but not least, answer.push, math.absolute, left minus right. And then we will return our answer array at the end. Like I said, this is a lot of code for a problem this simple. And if you look at the constraints of this problem too, it's like 1,000 elements inside the array. You're never gonna wanna use O of n space and O of n time for a problem this small. But like I said, this idea, this concept, and this method of solving problems is a really good one to learn and understand, because you are gonna encounter some problems where it just doesn't make sense to do brute force, or you need it to make it actually a viable solution. So let's go ahead and test this out. All right, and we got 15, 1, 11, 22. I believe that was 15, 1, 11, 22. Let's post it into LeetCode to make sure we've covered all of our edge cases. There we go. And this one is actually surprisingly saying it's beating almost 90% of everybody, which is surprising to me, especially here, because I know there's people who submitted their brute force solution for this problem, and that's not using any extra memory. Same with this problem that we're going to do now. So I'm going to go ahead to our one pass. And so our one pass solution is, before we even start iterating over this nums array, we're going to find out our right sum. Or you could just call it total sum. I like to call it right sum because it's only going to be our total sum on the first element, and once we move to the next element, it's not a total sum anymore, it's a right sum. But even on the first element, it's still the right sum. So we're going to use right sum for this, and we're going to use a left sum. So the idea here is we're going to iterate over this entire array once, calculating the right sum. Since we're starting on the left, we're just going to calculate all of these, and that's going to end up being 25. We're also going to initialize our left sum to 0. And so the idea here is when we start iterating over our nums array, so we're on this first element, before we do our main calculation, the math.absolute left minus right, we will subtract our current element from our right sum. So we'll get 15. Now 15 is the total of the elements to the right. Left sum, it's 0. So we'll perform our calculation, and then before going to the next iteration of the loop, we'll add our current element to left sum, and then we'll move to the 4. So we'll move to the 4. Now we want to do the same thing, our left minus right, but right now our current element is still in our right sum, and so we want to subtract our current element from our right sum before we do our main calculation. Do our main calculation, then we take this, add it to our left sum, move to the next one. Here, same thing. Our our current element is still inside of our right sum, and so we want to subtract that before performing our main calculation. Perform our main calculation, add our current to our left sum, and then move to the last one. Before performing our main calculation, subtract our current from our right sum, and perform our main calculation. So it's pretty simple. What we're going to do is we're going to create our answer array to store our new values. We're going to find the total sum of the nums array, and we're going to initialize a left sum variable to 0. Then we're going to iterate over nums array one at a time. For each element, we're going to subtract the current number or the current element from nums from, we'll call this our right sum or total sum, whatever you choose, whatever's more clear for you, to receive accurate representation of what we're subtracting. Only because if we don't subtract this, we're not going to have an accurate right sum. So an accurate representation of what we're subtracting, because we do not want to include our current element. All right, so that makes sense. And then we're gonna perform our main calculation. So push the absolute value of left sum minus right sum to answer array, and then add our current element's value to left sum, so left sum is accurate on our next iteration. Easy enough. So we'll go ahead and create our answer array. We'll go ahead and find the total here. So we'll just say let right sum, and like I said, you could use total as well. I just think right sum is a more accurate description throughout the entire problem from beginning to end, whereas total sum becomes inaccurate after the first element. It's not the total sum anymore, it's just the right sum at that point. So we'll do nums.reduce, use this built-in method. We'll have our accumulator, our current. If you don't understand what this built-in method does, just go ahead and do a Google search, and then we'll start it accumulating at 0. So we have our right sum, that's going to give us the sum of the whole thing, and then we'll do left sum initialize to 0. Iterate over our array from I equals 0 while I is less than nums.length, I plus plus, and then we'll perform our main logic here. So it's very, very simple. We're subtracting our current element from our nums, and so we're going to do right sum minus equals nums I, so we're just subtracting the current element that we're on right now from our right sum to make it accurate. Then we're going to do answer.push math.absolute left sum minus right sum. Should be good there. And then we just want to add our current element to left sum. And this right here seems to be the best solution. It's going to be O of n time, because we're iterating over the array here. We're also iterating over it here, but this is not inside the for loop, so we have an O of n here, and then we have an O of n here, so it ends up being O of n time complexity overall. This is O of 1, O of 1, O of 1, And so we end up with an O of n time complexity. We're actually creating this. So this is going to be O of n anyways, just with our answer array. But with this example, we have our answer array O of n, we have our prefix, which is O of n, we have our suffix, which is O of n, and then we have our O of n space. So we have our space is O of 3n, which you'd remove the constant 3, so it'd end up being O of n anyways, but it's still more than this one. And then we have our O of n here. I kind of like this solution better because if you're removing the constant from the O of 3n space, it still ends up being the same efficiency as this problem here. So this is O of 2n time complexity, still boils down to O of n, but O of just n space. So I would consider this better for space and worse for time. Actually, better for space and better for time. And then this one is just you have for loops nested within the for loop. So this is O of n squared time, which is not really good. You don't want that. And O of n space as well. So let's test this one out. We have node 3, 15, 11, 22. Cool. So 3, 1 pass. Let's test this in LeetCode to make sure that we're passing all the edge cases. I believe we are. Should be good to go. And that is that. So those are the 3 solutions. We have our brute force solution, our prefix, suffix, sum, which is definitely going to be useful when you move on to medium and harder problems. And then we have our 1 pass, which is my favorite of the 3. If you have any questions or comments, feel free to leave them in the comments and I'll get back to you. Have a good one.